May 1943, Oranienburg, 9 a.m. Inside a nondescript hangar, two brothers stood over a series of complex blueprints that would soon terrify the Allied High Command. Walter and Reimar Horton were not your typical aeronautical engineers. They were visionaries who believed the future of flight lay not in the traditional cigar-shaped fuselage with wings attached, but in a radical concept known as the flying wing. By the spring of 1943, the tide of the air war over Europe was shifting violently against the Luftwaffe. Allied bombing raids were becoming more frequent and more devastating, while the German interceptor force struggled to keep pace with the sheer speed and numbers of the incoming B-17s and Lancasters. The Third Reich was looking for a miracle, and the Horton brothers were ready to provide one that looked like it had been sent back in time from the 21st century. Hermann Göring, the head of the Luftwaffe, was desperate for a breakthrough. He issued what became known as the 3x1000 requirement. He demanded an aircraft capable of carrying a 1,000-kilogram bomb load at a speed of 1,000 kilometers per hour over a range of 1,000 kilometers. In the context of 1943 technology, this request was bordering on the miraculous. Standard piston engine fighters were reaching their physical limits, and early jet engines were notoriously thirsty for fuel, making long-range missions nearly impossible. To meet these specifications, an aircraft had to be incredibly light, exceptionally fast, and aerodynamically perfect. Most established aviation firms like Messerschmitt and Junkers thought the goal was a fantasy, but for the Horton brothers, it was the opportunity they had been preparing for their entire lives. The Horton brothers believed they had the answer in the elimination of drag. They realized that the greatest enemy of speed and range was air resistance. Every surface on a conventional aircraft, the tail, the rudder, the fuselage, created drag as it moved through the sky. Reimar Horton theorized that if you could eliminate everything but the wing itself, you would create the most efficient flying machine possible. The entire aircraft would become a lifting surface. There would be no parasitic drag from a tail section because there would be no tail. This was not just a design choice. It was a total reimagining of how a machine interacts with the atmosphere. They had spent years perfecting this theory with gliders, proving that a wing could be stabilized through complex twists in the airframe rather than vertical fins. The design they proposed, the Ho 229, was a masterclass in unconventional engineering. Its center section was constructed of welded steel tubing, while the wings were made of specialized plywood. This wasn't just a matter of resource scarcity. The wood construction made the aircraft lighter and gave it a smoother surface than the riveted metal skins of the era. Most intriguingly, Reimar Horton began experimenting with a mixture of charcoal dust and sawdust within the glue layers of the plywood. His primary goal was to make the aircraft fire-resistant, but in doing so, he accidentally created a radar-absorbent material. Decades before the term stealth was even coined, the Horton brothers were building a plane that could slip through the electronic eyes of British radar stations. By 11:15 a.m. on the day of their first major pitch to the ministry, the brothers had convinced the leadership that the flying wing was the only way to meet Göring's impossible 3x1000 goal. The project was given the highest priority. If successful, it would have been a ghost in the sky, a jet-powered phantom capable of striking London before any alarm could be raised. The integration of the Junkers Jumo 004 jet engines presented its own set of nightmares, as the brothers had to find a way to protect the wooden frame from the blistering heat of the early turbojets. They developed a cooling system that channeled air along the wing's surface, a solution as elegant as the plane itself. As we look back at the jagged, bat-like silhouette of the Ho 229, we see more than just a failed experiment of a collapsing regime. We see the DNA of the modern age. The Horton brothers weren't just building a weapon. They were chasing a pure mathematical ideal of flight that the rest of the world wouldn't catch up to for another 40 years. When the B-2 Spirit stealth bomber finally took to the skies in the late 80s, it bore a haunting resemblance to the wooden ghost created in a German workshop. The Hortons proved that even in the darkest hours of human history, the reach of the human imagination can trans its era, leaving behind a legacy of innovation that continues to shadow the clouds of the present day. It remains a poignant reminder that the future is often built by those who are brave enough to discard the rules of the past, even if the world isn't yet ready to follow them. February 1944, Göttingen, Germany. Inside a nondescript hangar, Reimar and Walter Horton stood over a skeletal frame that looked more like an avian nightmare than a conventional weapon of war. While the Third Reich's industrial machine was grinding toward collapse under the weight of Allied bombing, the brothers were obsessing over a concept that most traditional engineers dismissed as madness. They were not merely building a faster fighter. They were attempting to master the invisible. The Ho 2-29 was an exercise in radical minimalism, born from a desperate necessity to bypass the shortage of strategic metals. Aluminum was a luxury the Luftwaffe could no longer afford in bulk, so the Hortons turned to the oldest building material known to man, wood. To the casual observer, a wooden aircraft in the age of jet engines seemed like a regression. Yet, the engineering behind it was anything but primitive. The Hortons utilized a sandwich construction, layers of thin plywood bonded together with specialized resins. This was the foundation of a theory that would not be fully realized for another 40 years. By eliminating the vertical tail and the distinct fuselage, they created a shape that naturally deflected radar waves, rather than bouncing them straight back to the receiver. But the brothers went a step further, experimenting with a mixture of charcoal and glue that they applied between the wooden layers. They believed this carbon-rich layer would absorb electromagnetic radiation, essentially making the aircraft a ghost on the primitive radar screens of the mid-40s. This was not just a byproduct of resource scarcity, it was a deliberate attempt at what we now call radar cross-section reduction. Work often continued deep into the night, the brothers consulting with technicians at 2 a.m. to solve the issues of weight distribution and balance. In a flying wing, the center of gravity is an unforgiving master. Without a tail to provide longitudinal stability, the entire aircraft had to be shaped with a specific aerodynamic twist, a concept known as bell-shaped lift distribution. This was an aerodynamic puzzle that required precision beyond the tools of the time. The brothers were operating on intuition and slide rules, pushing the boundaries of fluid dynamics while the world outside their workshop burned. At 9 a.m. on test days, the tension in the hangar was thick enough to cut. Every rivet, every ounce of glue, and every shard of charcoal was a gamble against the laws of physics. They had to ensure that the skin of the aircraft could withstand the stresses of high-speed flight without peeling apart, a common failure in early high-performance wooden designs. They were also grappling with the immense heat generated by the Junkers Jumo U-4 jet engines. Placing these roaring infernos inside a wooden frame was a recipe for catastrophe. The Hortons engineered a clever cooling system, using the air intake to shield the wooden spars from the 1200-degree exhaust. It was a masterclass in compromise, turning a flammable liability into a streamlined asset. This focus on low observable characteristics was so far ahead of its time that contemporary Allied intelligence did not even have a name for it. They saw the flying wing as an aerodynamic curiosity, missing the deeper implications of its skin and shape. They saw a desperate German attempt to build with scraps, failing to realize they were looking at the ancestor of the modern stealth bomber. Decades later, when engineers from Northrop Grumman performed a full-scale forensic analysis on the surviving prototype, they were stunned to find that the Hortons' theories held weight. The charcoal glue mixture, though crude compared to modern radar-absorbent materials, did indeed have a measurable effect on radar absorption. The brothers had stumbled upon the core principles of stealth technology before the term even existed. They understood that the future of air superiority was not just about speed or altitude, but about the ability to remain undetected. They were fighting a war of frequencies and wavelengths. Even as the ground beneath them was being retaken by Allied forces, the legacy of the Ho 229 is a complex tapestry of brilliance and tragedy. It represents a pinnacle of human ingenuity applied to a cause that was fundamentally destructive. The Hortons were visionaries working in a vacuum of morality, driven by a singular obsession to solve a problem the rest of the world had not even recognized yet. Their work serves as a chilling reminder that technology itself is neutral. It is the intent behind the design that defines its place in history. They took the simple materials of a forest and transformed them into a machine that seemed to come from another century. Looking back at the charcoal-smeared wood and the sweeping curves of the flying wing, we see the blueprint for the modern age. The B-2 spirit is the spiritual descant of those late-night sessions in Göttingen. The Hortons proved that when resources are scarce, imagination becomes the most powerful fuel of all. They taught us that to truly innovate, one must be willing to look past the limitations of the present and peer into the fog of the impossible. The ghost in the hangar was never just a plane. It was a premonition of a world where the most dangerous weapon is the one you never see coming. It stands as a testament to the idea that even the most radical dreams can leave a permanent mark on the sky, casting a long, silent shadow over everything that followed. The wings of the future were carved from the wood of the past, proving that genius often waits for the world to catch up. January 1944, Oranienburg, Germany, was the birthplace of a machine that felt like a visitor from another century. Reimar and Walter Horton were no longer merely perfecting the art of the sailplane. They were preparing to marry the ancient principles of the flying wing with the raw, terrifying power of the jet age. The Horten HX, which would eventually be designated as the Ho 229, was a radical departure from everything the Luftwaffe understood about aviation. By removing the fuselage and the tail, the brothers believed they could eliminate the drag that held conventional aircraft back. But to make this wing truly lethal, it needed a heart of fire. The transition began in earnest as the V1 glider proved the stability of the shape. Now, the second prototype, the V2, would undergo a transformation that pushed engineering to its absolute limits. The chosen power plant was the Junkers Jumo 004, the world's first production turbojet. However, this engine was never designed for a flying wing. It was a bulky, temperamental beast that generated immense heat. Placing two of these engines side by side inside a wooden airframe was a recipe for disaster. The Horton brothers had to shield the plywood structure with steel plates and divert cooling air over the internal components to prevent the plane from incinerating itself before it even left the runway. Every inch of the V2 was a battle between old-world materials and new-world physics. Because the flying wing had no vertical stabilizer, the engines had to be buried deep within the center section, which affected the balance and the airflow over the entire surface. At 11 a.m. on a cold morning in early 1945, test pilot Erwin Ziller climbed into the cockpit to see if this marriage of wood and fire could actually hold. There was no backup, no safety net, and certainly no tail to correct a spin. The controls were connected to a complex system of elevons and spoilers that required an incredibly delicate touch. As the Jumo engines roared to life, they didn't just push the plane, they transformed its entire aerodynamic profile. Ziller's first flights were a revelation. Observers noted that the aircraft was exceptionally fast and possessed a maneuverability that defied its size. But the marriage remained fragile. At 1:30 p.m. on a later test flight, the inherent dangers of early jet technology became a tragic reality. One of the Jumo engines suffered a catastrophic failure mid-air. Smoke filled the cockpit, and the asymmetric thrust proved too much even for Ziller's exceptional skill. Without a tail to counteract the drag of the dead engine, the wing became uncontrollable. At 1:45 p.m., the prototype crashed, claiming the life of the pilot and the only flying jet-powered wing the world had ever seen. Despite the loss, the technical details of the Ho 229 continued to fascinate intelligence officers who would eventually capture the third prototype. The aircraft was partially coated in a mixture of charcoal dust and glue, a choice Reimar Horton later claimed was intended to absorb radar waves. While modern testing suggests this may have only provided a modest reduction in detection range, the intent was undeniable. The Horton brothers were conceptualizing the first stealth fighter. They weren't just thinking about speed. They were thinking about invisibility on a battlefield where the enemy's eyes were made of radio pulses rather than glass and optics. The tragedy of the Ho 229 lies in the paradox of its existence. It was a marvel of pure engineering born from one of the darkest eras in human history. The Junkers Jumo 004 was the engine that changed the world, but in the hands of the Hortons, it was harnessed to a vision that was 50 years too early. The aerodynamic stability they achieved without a vertical stabilizer is a feat that modern fly-by-wire computers struggle to replicate. In 1945, it was done with mechanical linkages and a deep, intuitive understanding of the wind. As we look back at the captured V3 prototype that eventually made its way to the United States, we see more than just a failed experiment. We see the DNA of the B-2 spirit and the future of stealth technology. The Horten Ho 229 was a bridge between the era of wood and canvas and the era of titanium and carbon fiber. It reminds us that the trajectory of human innovation is rarely a straight line. It is a series of radical, jagged leaps, fueled by the desperation of war and the boundless imagination of those who refuse to believe in the impossible. The flying wing remains a silent promise of a future that would eventually arrive, but only after the world had finished burning the foundations upon which it was built. We are still flying in the shadow of that bat-like silhouette, forever chasing the ghost of a genius that saw the sky differently. February 2nd, 1945, at the Luftwaffe airfield in Oranienburg, the freezing winter air was shattered by a sound that belonged to another century. A low, guttural roar vibrated through the snow-dusted tarmac as the Horten Ho 229 V2 prepared to defy the conventional laws of aviation. To the observers on the ground, the machine looked less like a plane and more like a silver shard fallen from the stars. It lacked a tail, a fuselage, and the sharp angles that defined every other fighter in the German arsenal. It was a pure, aerodynamic dream shaped into a lethal weapon of war, a flying wing that promised to rear the Allied air defenses obsolete. At exactly 11 a.m. that morning, test pilot Erwin Ziller climbed into the cramped, forward-slung cockpit. He was a man of immense skill and steady nerves, chosen specifically because the flying wing was a beast that required a delicate, almost intuitive touch. As the twin Junkers Jumo 04 jet engines surged to life, the aircraft didn't just take off. It asked with an effortless grace that stunned even the Horton brothers. During these early trials, the V2 prototype performed beyond their wildest expectations. It was fast, reaching speeds that threatened to leave the fastest Allied piston engine fighters in the dust. More importantly, its handling was remarkably stable for a design that lacked any vertical surfaces. Ziller reported that the wings sliced through the air with minimal drag, displaying a maneuverability that would make it a nightmare for B-17 bomber crews to track. Before the fire and the twisted metal, there were moments of pure, unadulterated triumph. In those first few weeks of February, the V2 prototype proved that the flying wing was not just a theoretical curiosity. Ziller had pushed the aircraft to over 500 miles per hour, making it one of the fastest objects on the planet. He had even engaged in mock dogfights against an Me-262, the world's first operational jet fighter, and the Horten wing had outperformed it in almost every turn. Reimar Horton had even experimented with a mixture of charcoal and glue between the plywood layers of the wing, a primitive but visionary attempt to absorb radar waves. They were building a ghost, a plane that could strike and vanish before the enemy even knew it was there. For several days, it seemed as though the Horton brothers were on the verge of a miracle. The German High Command, desperate for a Wunderwaffe to turn the tide of a losing war, watched with bated breath. But the beauty of the design masked the terrifying fragility of the technology powering it. The Jumo 04 engines were temperamental at best, prone to catastrophic failure after only a few dozen hours of operation. On February 18, 1945, the streak of success came to a violent and tragic halt. At 2:45 p.m., Ziller took off for what was intended to be a routine flight to test the aircraft's performance at various altitudes. For the first 45 minutes, everything appeared normal as the silver wing banked over the German countryside. But as the clock struck 3:30 p.m., disaster struck. Eyewitnesses on the ground heard a sudden, sickening change in the engine note, a high-pitched whine followed by an ominous silence. One of the jet engines had flamed out. In a conventional aircraft, an engine failure is a crisis. In a flying wing, it is a fight for survival. The loss of symmetrical thrust caused the Ho 229 to yaw violently, fighting the pilot's every input. Ziller, showing incredible courage and a desperate loyalty to the project, refused to bail out immediately. He fought the controls, attempting to restart the engine and save the priceless prototype. He made 3 low-level passes over the airfield, desperately trying to bring the wing down in a controlled landing. On the final approach, the aircraft stalled. The wing dipped, the silver skin caught the cold afternoon light one last time, and the machine cartwheeled into the earth just outside the airfield perimeter. The explosion was deafening. Erwin Ziller was thrown from the cockpit and died shortly after. With him died the momentum of the project. The V2 was destroyed, and while work continued on the V3, the clock had finally run out for the Third Reich. The tragedy at Oranienburg was more than just a failed test. It was the hover vision that was simply born too soon. When Allied troops eventually captured the Gotha factory, they didn't find a fleet of super weapons. They found skeletons of wood and steel that looked like artifacts from a future they couldn't yet comprehend decades later. When engineers began developing the B-2 Spirit stealth bomber, they looked back at the Horton designs with a mix of awe and validation. They realized that the brothers hadn't just built a plane, they had unlocked a secret of the sky. The Ho 229 was a ghost that haunted the halls of aviation history for 50 years before the world finally caught up. It serves as a haunting reminder that genius is often indifferent to the cause it serves. The flying wing was a masterpiece of physics born from the darkest era of human history, a testament to the fact that even in the midst of total destruction, the human mind remains capable of reaching for the sublime. We look at that bat-like shadow today and see not just a weapon, but the heavy price of progress and the lonely fate of those who see the world not as it is, but as it could be. May 1945, in the shattered remnants of the Gotha wagon fabric factory in Thuringia. The air was thick with the smell of scorched oil and the metallic tang of spent ammunition. But as American soldiers pushed through the hangar doors, the scent of the future took over. They found themselves staring at a machine that defied every law of aviation they knew. It was a charcoal gray wing, smooth as a river stone, lacking any tail or rudder. This was the Horten Ho 229, a craft so radical it seemed to have fallen from another dimension. This discovery was the catalyst for Operation Lusty, the United States' desperate race to seize Nazi Germany's most advanced aeronautical secrets before they could vanish into the encroaching Soviet zone. Colonel Harold Watson and his team, nicknamed Watson's Whizzers, were the hunters tasked with this high-stakes scavenging. At 8 a.m. on a crisp spring morning, Watson stood over the wooden airframe of the V3 prototype, realizing that the technology before him was not just a variation of Allied jets, but a total departure from them. The Americans knew that the Iron Curtain was already beginning to desk, and whatever they did not crate up and ship out immediately would eventually be used against them in a new kind of conflict. The Whizzers were in a frantic sprint against time and geography. Thuringia was slated to fall within the Soviet occupation zone, meaning every hour spent documenting the Ho-229 was an hour closer to a confrontation with the Red Army. The recovery process was a logistical nightmare. The flying wing was not built for easy transport. Its delicate plywood skin and massive wingspans required specialized handling. At 1:30 p.m. on the third day of the recovery, engineers began the painstaking process of dismantling the craft into sections that could fit onto heavy-duty trailers. They worked under the constant threat of Soviet patrols venturing across the fluid borderlines. As they peeled back the outer layers of the aircraft, they discovered something that sent a wave of unease through the intelligence community. The aircraft was coated in a mixture of charcoal and glue, a primitive but ingenious method of absorbing radar waves. It was a revelation that hit the team like a physical blow. The Germans had not just been building a faster plane, they had been building a ghost by 4 p.m. That afternoon, the crated remains of the Ho-229 were on a truck headed toward the port of Cherbourg. This was Operation Lusty in its purest form, the systematic stripping of a defeated nation's intellectual property. The Americans weren't just taking the planes, they were taking the math, the physics, and the men who understood them. When the V-3 prototype finally arrived at the Freeman Field Research Center in Indiana at 11:15 a.m., several weeks later, it was treated as the most significant prize of the war. American engineers, including those from Northrop, pored over the Horton brothers' designs with a mixture of professional jealousy and profound awe. The influence of this captured technology would ripple through the decades. Long after the fires of World War II had been extinguished, the captured Ho-229 became a silent mentor to a generation of Cold War designers. When we look at the B-2 Spirit today, we are looking at the refined, digital descant of that wooden skeleton found in a Thuringian hangar. Operation Lusty succeeded in its mission to bring the future to American shores, but it also left us with a haunting legacy. It forces us to confront the reality that the most terrifying weapons often possess the most breathtaking beauty. The race to capture Hitler's secret wings was more than a search for tactical advantage. It was an admission that genius is a resource as valuable as oil or steel, regardless of its origin. The Horton wing remains a solitary figure in the halls of history, a bridge between the propeller-driven past and a future of invisible, silent power. It stands as a testament to a moment when the world broke apart, and in the cracks of that destruction, we found the blueprint for the next century. We are left to wonder how much of our progress is built on the ruins of our darkest hours, and whether the wings we fly today still carry the shadows of the era that birthed them. In the flying wing was never just a plane. It was a warning that the mind can soar to incredible heights, even when the soul is grounded in the depths of human depravity. Late summer 1945, at the Wright-Patterson Air Force Base in Ohio, American engineers stood in a heavy, contemplative silence as they stared at a shape that defied every known convention of the era. Before them sat the Horten Ho 229 V3, a jagged, wing-only phantom pulled from the smoking wreckage of a collapsing Reich. To the men who unloaded the crate, the aircraft looked less like a machine of the 1940s and more like an artifact from a distant, perhaps terrifying, future. It was sleek, predatory, and disturbingly advanced, representing a leap in aerodynamic logic that many refused to believe had originated in a factory powered by the forced labor of a dying regime. It was a ghost that had crossed the Atlantic, carrying with it the secrets of a war that had pushed human ingenuity to the brink of the impossible. For decades following the war, the Ho-229 remained a shadow in the annals of aviation history, a curious footnote of German Wunderwaffen that never quite took flight in time to change the outcome. While Reimar and Walter Horton vanished into the post-war haze of South America and quiet academic lives, their radical ideas took root in the fertile, secret soil of American aerospace. It is impossible to look at the haunting profile of the modern B-2 Spirit or the B-21 Radar and not see the genetic blueprint of the Horton wing. By 4 p.m. on any given day during the height of the Cold War, designers at companies like Northrop were wrestling with the exact same stability and control problems that the Horton brothers had faced in the woods of Göttingen. The quest for the pure wing was no longer a fringe obsession. It had become the holy grail of global air power. In the early 2000s, the legacy of the Ho 229 moved from the realm of theory into the laboratory. Engineers at Northrop Grumman, the very architects of modern American stealth, sought to settle a long-standing debate. Was the Ho 229 the world's first stealth bomber by design, or merely by a stroke of aerodynamic luck? At 8:15 a.m. on a clear morning in the Mojave Desert, a full-scale replica of the Ho 229 was raised onto a radar testing pole. It was built using the original materials: thin plywood, charcoal-infused glue, and a steel frame. When the radar beams hit the wing, the results were chilling. The aircraft possessed a signature significantly smaller than any contemporary fighter of its day. Even if the Horton brothers had not fully mastered the complex physics of radar-absorbent materials, their intuition had led them to a shape that the world's most advanced sensors would have struggled to find. It was a weapon designed for a war that could have redefined the map of the world had it arrived just a few months earlier. This realization brings us to the most uncomfortable intersection of history, the point where genius meets depravity. We often speak of technological progress as a linear climb toward a better world, yet the Ho 229 serves as a stark reminder that innovation is frequently forged in the hottest fires of human suffering. The flying wing was a product of a regime that prioritized ideological conquest over the basic value of human life. Every rivet driven into the airframe and every layer of wood glued to its ribs was a testament to the desperation of an empire that saw science as a tool for subjugation. When we admire the elegance of its curves or the brilliance of its lack of a tail, we are also forced to acknowledge the darkness of its origin. The bridge between the 1944 wing and the modern stealth bomber is paved with the moral complexity of Operation Paperclip, where the sins of the past were often quietly exchanged for the technological supremacy of the future. Today, the original Ho 229 sits in a restoration hangar at the Smithsonian, a rusted and skeletal reminder of what might have been. It serves as a bridge between the propeller-driven past and a future of invisible, silent power. It stands as a testament to a moment when the world broke apart, and in the cracks of that destruction, we found the blueprint for the next century. We are left to wonder how much of our progress is built on the ruins of our darkest hours, and whether the wings we fly today still carry the shadows of the era that birthed them. The flying wing was never just a plane. It was a warning that the mind can soar to incredible heights even when the soul is grounded in the depths of human depravity. The silence of a stealth bomber overhead at 3 a.m. is not just the sound of advanced engineering. It is the whisper of a ghost that refused to stay buried in the ashes of 1945.